David Brown from BroadBit Batteries. The topic of his presentation is now deviating, I think, a little bit from our sodium-ion battery discussion so far. Now it's sodium salt battery technology, status in manufacturing and application. Stage is yours.
Okay, thanks. Can you see my presentation?
We can see your presentation.
All right, very good. So I'm going to talk about our sodium salt battery technology. First, before I go into that, I want to say a few words about our company because you may not know about us. So we are a private company founded in 2015. We're based in Finland, just outside of Helsinki, and we do battery components and batteries, and I'll explain the big business here. So we have two lines of products. We have one, an evolutionary approach to improve lithium ion with a new electrolyte and a new cathode. And then we have our revolutionary product, which is our sodium salt battery. And in this talk, I'll only be talking about the sodium salt. Just on the big picture, our lithium products are ready. We're now scaling production. Our sodium products are still in development. We're about TRL 5, TRL 6 right now with those, but I'll show you the status. Along with the evolutionary approach, we also have a new water-based process to produce cathodes for our lithium. And I'll be talking about in this talk our revolutionary process to produce cathodes dry. But what's in common is we produce lower cost, higher performance, greener, safer, and more scalable batteries with both technologies. So now on to focusing on our sodium salt technology. So we have a unique operating principle for this battery. On the cathode side, we have a sodium salt crystal embedded in a carbon matrix. We can also add a metal oxide for certain applications, and I'll talk about that in more detail. On the anode side, we just use metallic sodium with electrode deposition. So this is not not a metal ion battery. In between, we have an inorganic SO2-based electrolyte. It is non-flammable, so we use no flammable organics in our electrolyte. It has an extremely wide operating temperature range, and it has extremely high ion mobility. So we can get very high power out of our batteries. And a side effect of that is we can use extremely thick cathodes. And I'll explain the implications of that as well. And in terms of the material, it's extremely scalable and sustainable. So we use no rare or toxic materials in our battery. So for the high energy version of our battery, you see the main ingredients here: table salt, NaCl, sand, SiO2, carbon, and sulfur. And sulfur is actually a waste product from petroleum refining, and it's a very, very low cost ingredient to our batteries. We also have a high efficiency version where we add copper oxide to the cathode as well. We have a high power version as well, but I won't go into any details about that. So I want to state clearly that we are not a sodium ion battery. We do not rely on intercalation to store charge. And because of that, we can get significantly better performance. So we can get up to 300 watt hours per kilogram if we optimize the cell. And of course, we're using an inorganic non-flammable electrolyte, so it's much safer than an ion battery using organic solvents. And then for the processing, we have our dry liquid-free process. And in that process, we eliminate many of the expensive steps in the cathode production process. For instance, we eliminate all the mixing steps, the dispersing steps, the drying steps, and the solvent recovery steps, which you need when you're using toxic, expensive organic solvents. And we can reduce the cost dramatically. So if you look at a traditional industrial wet coating process machine with a slurry coater, that CapEx is about 15 million euros. It uses about 500 kilowatts of energy. The processing materials are expensive and dangerous, and it uses a significantly large factory space. So we replace that with this little machine you see there on the right. It costs a fraction of the amount. The first machine costs about $500,000, and it'll get cheaper from there on. We use about 10 kilowatts of energy for it. We have no processing material costs. It takes up a tiny factory footprint. And of course, with no solvents, it's much more environmentally friendly. And that's the innards of that machine. So basically you put a dry powder in one end, and out the other end you get a a two-sided coated cathode, which